Hello guys, let's solve another LeetCode problem, jump game. It's 55 and it's medium difficulty. We are solving blind 75 LeetCode questions and it's in the dynamic programming section. We already solved a couple more dynamic programming problem in the previous videos. So let's go and solve this one. These very interesting questions because it's a common question according to the FANG interviews. So the problem is you are given an integer nums. So this is a nums integer array. You are initially positioned at the array's first index. So basically you are in actually the first location, that means 0th location. And each element in the array represents the maximum jump length at that positions. So basically for this input case, what you can do, so if you have 2, 3, 1, 1 and 4, and the location is same as, let me just do it. The first location is 0, this is 1, this is 2, this is 3, and this is 4, this location, right? So each of the value represents how many position you can jump. So if you are in 0th location, you can basically jump maximum 2 locations. So from this 2, you can actually jump either 1 or you can jump 2. What about 3? From 3, actually, you can jump 3 locations. So from 3, you can go to, so if 3, you can go to 1 location, you can go to here, and also you can go to here. So basically, from each index, you can jump with the maximum value of these one. Return true if you can reach the last index, or false otherwise. That means if this is the last index is 4. If you can reach that location, you want to return true. Otherwise, you will want to return false. So there are a few tricky use cases for this problem in the LeetCode. So you need to be really careful how you want to solve this problem. So let's assume if your length is only 1, right? And the input is, so because the length can be minimum 1, right? So what will happen actually in that case? So if you have only one value, that could be either 0 or 1, right? So, or can be 1, right? Or any of the values. So if the value nums of I start with 0, that means the lowest it can be 0. And what will you do in this case? If that's the case, for this one, you are already in the 0th location. So you basically want to return true. And anything you have, the 1, 2, 3, you basically return true. So for any of the length, you will return just true here. So that's one of the use case you need to worry about. How we'll solve this problem? We basically want to check the maximum length you can go from each of the index. And if we can, the maximum position we can reach at the end of this one, like n minus 1. So basically this 4, then we can return true. Otherwise, we will return just false, right? So we'll keep track of 2 variable, right? So current max, what we can go from there. So if we have a variable like current max, right? We'll start with 0. And for each of the location, we will actually update this current max. And for example, if you add 0 plus, so you are in the 0th location, you added 1. So that means 2, then you can maximum reach 2 position, right? And we'll update this value accordingly based on how we can go about it, right? So yep, let's go ahead and solve this coding problem. So the base case, if we have n, which is len of nums, and if your n is 1, that means if you are only one value, you basically return true. So this is the use case I was talking about, right? Now you will have current max. Current max, you are starting with starting location 0. And for index, for each of the location, we want to go to n-1. You don't need to go to the last location because you want to reach the last location. So if your index is less than or equal current index, you want to update the current max, right? Which will be max of whatever you already have. That means what position you already reached, or IDX plus nums of index. And finally, you want to just check that actually your current max is greater than or equal to n-1, right? Because if you can reach the last location, that's what you want to do. So what are the things we did? So we start with the first location, current max 0. And then we want to check for each of the indexes, index location from 0 to n-2 basically. So you want to, for each of these values, you want to check all of these. If your current index is less than the current max, so it should be current max, then you typically want to update the current max, right? And you're updating current max only if your IDX, the current location, and how much further you can go from these locations, right? Be careful about these if conditions. So what does it mean? It means actually, for example, this next input, right? So at first, this will be 0 plus 3, it will be 3, right? And second location, you can reach second location, right? Because the second location is less than IDX, right? Same as like for these ones, and you can reach this location. So what about 0? When you are in the 0, your IDX is actually 0, 1, 2, 3, and you are already this location, and the maximum you can go actually 0, and with this value, you can still keep 0 plus this value, right? So uh, however you actually started, you always end up the 0th location, right? And in the 0th location, your current max would be something like these locations, 0, 1, 2, 3, right? So you can only reach 3. You can't reach this 4th location. So basically your current max would be always n-1. Yep, so that's a easy problem if you know actually how to solve it. So a little bit tricky based on actually how you approach or actually update the current max. And don't forget about this condition, because this condition actually means that if you are able to actually reach this current index, if you can't reach this current index, then you won't be able to go from that location, which is true for this 0 value. So from the runtime complexity wise, you are just going through the loops once. So it will be, this for loop will be order of n. You are not storing anything on except this current max. So it will be a linear time algorithm with actually constant space. So that's the best we can do for this problem. Yeah, thanks for watching. I will see you in the next LeetCode video.